at least get some more votes out today, and then see what we can do. So we'll stop around 5 minutes before and then discuss about the next book. Yeah, go ahead, Rajesh.
Great. Thank you. Thank you, Nipendra. I will share my screen. Let me know once it's available. Don't worry about the recursive screen share. Is my screen visible now?
Yeah, it is visible. You can remove the chat and we stop the chat, so that book can come. Okay, you can just maybe take that the book and the entire screen, I think. And I'll take the questions. If you have any questions, is there? I'll
Okay.
ping you.
Okay. Okay. I will restrict this.
Yeah.
Is this okay? Or I will go into slide share mode. So you'll not
Okay.
have.
Okay. That's fine. That's fine. Yeah. Go ahead.
Oh, this is to quickly switch back and forth.
Okay. Understood.
Uh, where is it? Where is it? Um, Slideshow. Yeah, we entered slideshow. So before jumping into the supply chain chapter, we'll quickly preview what we had discussed quickly. Last week we finished the chapter application consideration. This is all about how to configure a system. This is more of a developer thing, and how to enable logging and why it is important, how to do the metrics, why it's important. For example, successful metrics collection further after some time, once it's matured, it will be useful for billing kind of stuff. If you are into SaaS selling, this would be after a year or so, you can start charging customers based on the metrics, and that will be the useful stuff. Those are the stuff we were talking last time, how the life cycle of a container can go, what are all the provisions the Kubernetes have provided us, how to do the liveliness probe, all those things, and also how to pack the system, how to restrict resources for the pod, and in turn container running inside the pod. So these are the stuff we had spoken. Finally, we touched about tracing, how that helps in production system when it is, especially when you're dealing with lots of upstream and downstream. And we spoke about Yager and Zipkin. Those are the tools. If you are interested more, go and look. Especially I like Zipkin. Yeah, Nipendra was talking about Yager on his experience also last week. Yeah, so let's jump into the supply chain. This is more of a platform engineering teams stuff when it compares to the last one. Last one is mostly dev stuff. This one is platform engineering stuff, and it helps how to transport code from dev to production. What are all the steps required to take them from their machine to production systems? That's what it also talks about. Mainly covering two sections, as you see: container management, how to do the container, and the role management, how what kind of user to be used, and the best practices. Some of the latest enablement on building the container. We can talk once we are inside. Then a little bit about image registries. We can also talk about that. This is something container factory you might have been already working on it. And then continuous delivery. Here is where we will talk about Argo CD and other stuff. Yeah, mainly these things: building a container and the image registry. So once you can build a container, you need something to store and retrieve. That's where the image registry comes in picture. Then finally, once you have something built and stored somewhere, it needs to be deployed. That's where the Argo CD comes in. So let's dive deep here. So the book, first of all, starts with the philosophy that Kubernetes is not answer for all of the deployment. So the overall aim of us as a platform engineering team, wherever possible, what is the best solution to take it forward, how to make the deployment faster. That is the main scope. That's a counterintuitive from the author itself, but yeah, that's what it is. It's not the answer for everything. When you have very complex services, for example, some almost 20 to 30 services, then this will be a good good solution. If your project has one or two solutions or five solutions, services, a combination of UI and services, then you could just handle with the virtual machines. In a nutshell, that is what the introduction talks about. Then a discussion about building a container, how we usually build a container. So what are the best practices? Those are the stuff it's being discussed here. For example, when you build a container, set of queries can we run our builder as root? No. So we can't run as a root. The reason is, um, when you when you run a container as a root, it has all the capability, all the elevated rights. You can do anything. So if someone have a hand on the container, they could get the entire system. So always run a container as a non-root user. That is the best practice. And when we build the container, we'll need to mention a specific version instead of going for latest or anything like that, to avoid a problem. That we, I think, everyone here must be knowing that everyone we are doing that. It's a simple best practice. That's all. The book also asking to do as a best practice. And also when we are pulling image, Docker image, it always has to be official one, not something that is from unknown user or someone who is not very familiar. For example, when you pull an image, it is for example HashiCorp image. If we have something that is very familiar, that would be great. And also you need to build the image as lean as possible to make sure it doesn't have unnecessary dependencies, and booting faster. It has to be a light. And what I'm missing, also, yeah, you'll need to handle catching. So in terms of using the directories and the stuff, you need to make use of catching to make it really faster. um, yeah, that's it. And on the best practices, now the golden base image. So golden base image is something like a vetted one. I think I don't know whether it is used everywhere, but it is used mostly in the government systems where the vetted system is mandatory. So this is a snapshot of all the pre-configured stuff, uh, including the configuration and the users who can access the system, all those things, all required thing, which is ready to boot. It doesn't require any further configurations with Ansible or anything like that. Just boot and mount and boot. That's what the golden image is. So the book says that when you are using golden image, don't add any further layers on top of that, because the golden image gone through a lot of rigid process for waiting. Waiting means a security checks, all those things. It has gone through and passed the security checks, and so adding any further libraries on top of that base image will not be any beneficial. Even it is a beneficial, it is not secure. The very purpose of having golden image is to have a secure image, and that also helps us to uh, easily scale and increase the speed in terms of booting it as required. So never use library on top of golden image. That's I think here. So the golden building golden image is something that comes in two flavor. You can either buy that from Amazon, something like AMI. Also, you can build. So building on your own can be using something like a Packer. Packer is a tool which will help us to copy the good known virtual machine with all the configuration. It will ghost it and burn the image. And another way is you can buy that in Amazon. There are other vendors also producing golden image. For example, Oracle also. Yeah, just for name few, you can build the golden image as well. But that needs to have all the pipeline security scanning and everything within your infra, which we'll talk again on the container registry. Yeah, again, here, what we spoke earlier is what being discussed here. The base image, how you can choose the base image. It needs to be from the official publisher, and it also has very transparent process, how it is built and all those things. These are the something we are regularly doing, this kind of stuff. We never get something that is from user X. For example, if I publish image, you are not going to use that because I'm not org or any reputed stuff. Yeah, that's an example to talk about this situation.
Maybe
uh,
we can ask others. Have you guys built your own base image, golden image in your company? And if yes, how are you doing that?
uh,
Anyone?
I think,
Yeah, go
yeah,
ahead. Go ahead.
I'll wait for other participants to talk about, otherwise
Yeah, correct.
keep quiet for another second.
Hey, hi. In our company, like we are taking many of the base images, say like CentOS or Ubuntu, and on top of that, we will be installing, say like Nginx or whatever the packages we are requiring. So we are installing whatever the softwares we require, and on once we install whatever the softwares we require, we are taking an AMI out of the machine. So once it qualifies security, then we'll make it as a golden AMI for our use case.
So you're talking about in terms of the VMs, right?
Yes, we are correct.
Yeah. Anything about containers as well?
Containers, yeah, we are following the same pattern for the containers as well, and on top of it, we will be copying our application code as well as any of the tools we will be requiring necessary for the application, and we will be creating our custom images from those.
Okay. Okay. So for containers, I'm not sure. I'm just no, no, not to. So for in general, right? For containers, I believe. Have you guys built an image from scratch? Like for example, you can just burn the your what do you call say your binary into that. So for example, if you say from scratch, right? Like
Mm-hmm.
in a Docker file.
Uh-huh.
Have you guys done anything like that? That you just start from like just dump a tar file and then make a image out of it.
Not in a workplace, but I remember I did for one of the samples some long time back,
Okay.
building a document from scratch.
Nice, nice. Okay. Anyone else doing the one from scratch? Like anybody build that base image from scratch? So when I say scratch, what I mean that, so for example, let's say if you have to build a virtual machine or the container image of Ubuntu, for example, right? So how the base image of Ubuntu would have been built, right? So if you look at that question, right? So the way it would do is there are some tools like Deb, Bootstrap, and other stuff, right? For example, if you just download the required binary and then just keep it into the folder and then give that folder into a container image, it works. So for example, think about I just want to have a container image which can just do ls command, for example. Now it's just building, right? Just the ls command or date command, whatever it is, right? Now to build a container image for that, what I can do is I can basically find out the dependencies of a given ls program. So if you know that there's a command called LDD. So if you do LDD command and with the ls command, right, you'll find all the linked libraries for that ls command. Now what you just do is you need to kind of copy all of that structure and dump into a folder, and we can keep it into our image and make it run as well. So you can have a single binary into an image and make it run as well. So for example, static go binary can be done like that. So yeah, Rajesh, you can share a use case if you have.
Sure, great. I think Nikhil, in your process, you are also, I believe, that the scanning contains the CV scanning also. Is that true?
Um, I think that will be taken care of like when we are, I mean, in our case, we are using ECR, AWS ECR. So I think ECR has that option already. So when we upload an image, it will scans for any of the vulnerabilities and gives a report, or at least
Oh,
shows what kind of and priorities of vulnerabilities we are having in the image.
okay, okay,
Okay.
all right.
Something on the chat as well. Frank says they're using Red Hat UBI. So I'm not used UBI, but I'm assuming that there is something in that ecosystem to bring up that base image. Yeah,
Great. Good
maybe
to
let me
know.
just check. Yeah.
Yeah, great. And there is something called Scratch itself, Nipendra. So
Yeah,
that resembles with what you said. It is a distroless image, something like Alpine. Alpine is something that are regularly used across building, across platform engineering for building the images. But this book also advises to use a distroless base image that is even lighter than Alpine.
right,
And when it comes to what is the difference between Scratch and distroless, is that Scratch is completely a distroless. What it means is it doesn't have a non-root user, which is not going to be very much useful. Uh, because we would need a non-root user to run a container in the runtime. So the distroless base image is what more useful in production. The URL is here, gcr.io/distroless base. This can be used. This will only have a very lean a required thing. This would not even have a command line. So this can't be SSH'd. So this is much secure than Alpine. This is a simple Docker representation of how this can be built. Anyone want to try? They can try. Yeah, again, this one is just talking about pinning the version means using exact version of the image, so that if any when it comes to latest and you are using the latest base image all the time, and you are not knowing that there is another latest version, and your system works fine on the prior version, and after it is built for a new change, it's going to break mostly. So it is always better to use the compatible version. For example, here 3.12. On top of that, you can run some other stuff, your own platform engineering stuff on top of this operating system. So it is going to be assuring that this is not going to break surprisingly. So that's the one practice. I think this is
That's the one other thing talked about is also pinning a specific package also. Like for example, in this, they're giving that image magic package version, right?
mm,
Even while installing any package, rather than just saying APK install image magic as a package name only, you also pinpoint the version as well.
yeah.
So that way, there's no surprises that would happen. Yeah,
Yeah, everywhere. Yeah, it is everywhere. The best practice is
correct.
to use the numbering. We will again touch this topic when we talk about tagging. This is a much relevant topic. Yeah, wherever possible, not avoid, completely discard using a latest or any generic pointing. Now we'll talk about build versus runtime image. So we do have two versions, right, for building any images. It has a build version. For example, you build a Java version, Java application. It would have a build artifacts, and also it will have a runtime artifacts. For building, you'll need all the JDK other stuff, but for running it, you will only need some few JRE files. So that is a difference between these two things. When you pack the container, you will need to do that in a multi-stage. When I say you, I think most of us we are doing it. It is anyone who is dealing with this has to go with the multi-stage. What it means is that you build the artifact, then point the artifact source for deploying it instead of completely taking the build output and placing it. So the build output have several files for its building process, but for runtime we only need a very lean amount of files. That's what it means here. For example, here in the book, it was shown as a Golang example. Um, there is an image being taken, and there is a working directory. Working directory again uh, makes things catched. Once it is referred, it will be there in catch. So it will speed up the process on building it and referring it in later stage. Then there's a copy and um, I don't know run go mod download means what it is in Go. I never worked on Go. Uh, then after the build stage is completed, now look at the deploy stage. It's that moment only it is referring the base image, distroless base image. The building is happening without even the distro image. So because it doesn't require a distro. Once packing started, we need a distro image. Then we need a non-root user. Then what are built in the previous step, it's being referred. That's what it means. From build means it refers the build stage and it takes all the references. My app slash my app, whatever
Yeah.
the
Rajesh,
directories.
if you don't mind, would you kind of talk about a bit on multi-stage build, or I can take it a bit.
Yeah, you can expand on it,
Yeah,
Nipendra.
sure. Thank you. So as you can see in that Docker file, there are two from instructions are there. This is just for people who are not aware of multi-stage build, which I'm pretty sure none of you, but just in case. So if you look at in that Docker file, there are two from statements are there. So Docker file which with two from statements which are, as we can see mentioned in the point one and point three, right? Which mentions that basically that that first, so there are two stages to it. The first from stage is doing the build process. So think about you are having a container image which has all of your compilers and everything else as well. Now, those things are not required to be given to a customer. So, for example, if you download a source code into a Docker image to build it, there is no need to give your source code to the customers unless you want to or you have to, correct? So in that case, what we just do is in the first stage, we just build the software, get the binary, and if you look at in the point five, the second last line in the Docker file, which says that copy from. So basically, it is copying from that build stage and copying it here. I think Rajesh already mentioned that, but just to kind of clarifying a bit more for if anybody is not aware of multi-stage builds. So the output of this Docker build file or Docker build process is just going to be what you have in the deploy stage output, which means a distroless image with your binary, not the remaining part, not the other part. So though it looks like the Docker file looks much, but the output of this Docker build process is going to be just that image of in the stage in the in the deploy stage with that distroless and that with the non-root user and just have that binary which you built previously. Yeah, that's all.
Yeah, great.
Just a quick question, Nipin. So that means that once the build stage completes, we will be having one image.
Yeah, one image you will have, correct. So the other images maybe as a part of the in the Docker and the Docker would have it, but whatever that minus tag you have given, right? For example, it's like my prod image, whatever, right? So you will have that prod image which contains only that particular part only.
So does that mean like we will be getting two images or
No, no, no. Output would be one image only.
okay?
But intermediate layers are managed by Docker, so Docker would be having in a cache. But for you, it just like the output of this build process is going to be a single image with just that particular the last piece of it.
Okay, but then what's the? I'm just trying to understand. Then what's the advantage of going for the multi-stage builds
Sure. So
or
simple,
Docker
right?
image?
Yeah, yeah, sure. So the simple is, for example, let's say you have to let's say compile a C program, correct?
Uh-huh.
For that you need a compiler,
Correct.
correct? And of course, if your code is on GitHub, you would have to have a code also in that image.
Correct.
Now, think about if you build an image from that, would you give that image to your customer? No, right? Because that contains the source code as well as your uh, packages for build process also, which is not required for the customer, right? So what you typically want is you just want to copy the binary out and put into a new image. So one way of doing it, you do it two different part itself. So for example, you take one image, you perform all the steps, whatever binary you got, you copy it outside, correct?
Okay.
Then you take another image, base image or distress image, and just copy the binary inside that and give a
Okay.
new image to it, correct? So that way, whatever you're giving to your customer, that contains only your the this or the whatever the base image and the binary, nothing else. So rather than doing in two separate stages, Docker has this Docker multi-stage build.
Okay.
So rather than, that's why you see two from instructions. Can you just open that particular para, Rajesh, in that book, that in that
Yeah, yeah.
section there. So as you can see here, this is the build stage, right? Yeah. No, no, keep it here, keep it. Otherwise, then we'll go there. So as you can see here, no, no, don't go. This reduces font actually. Can you go back to the previous one only, or keep it single page here, Rajesh?
Oh, yeah. Sure. I will.
Yeah, this is okay. So as you can see here in this Docker file, there are two from instructions are there, right? One at the beginning, golang 1.2 whatever, correct?
Okay.
And then there's a second from instruction which is at line number whatever step number 3. Can you come down on deploy stage? There's another from instruction is there, correct? The from instruction is there. So the first part of it just building the image and getting the binary out of it, which
Okay.
is your my hyphen app in the previous step, as you can see, run go build minus the my app. That's the binary, correct? And now what we are doing in the second last step, we are just copying from that to this particular image, new image what we're building.
Like basically the binary
Yes,
from the
just the
build.
binary, correct. That is what is happening here.
Okay. Okay.
Perfect. Make sense?
Got.
So,
Yeah. Got it.
is my understanding is correct? So I do not want to share my source code to the client.
Yeah.
So I will build it and share to the. No, I take the source code compile it, and then only give the compiled version to the client.
Correct, because I don't have to, because first of all, that image size would be large.
Yeah,
It may
yeah,
have a larger security surface, right? The surface of the security can go large. So
yeah.
I just want to keep it minimal. That is the
Yes,
whole
yes.
idea.
Yeah, that's the in the first from that is there. The Go source code is there. Okay,
Correct,
so
correct.
that's
Yes,
yeah, yeah. Okay,
right.
so this run go build will create the binary.
Correct. Yes, yes, you got it.
Yes. So yeah. Thank you, thank you.
Okay, great.
And one quick question for the distro business, like what is the OS flavor it having it?
So distroless generally, see, you can even skip the distro itself. Right? That's what distroless means. They don't have any distro per se. It just have enough thing to run the binaries of whatever is required.
Okay,
Right? For example, in Go, Go is anyway, if you it's going to be statically compiled, which means it has
yes,
all
yes,
dependencies. Correct. So
correct.
whatever required to run Go, that's all required there. Nothing else.
Okay,
Yeah. So just whatever is required rather than having the full blown OS, no OS, it's just a thing what is required to run that particular binary of yours. That's all. That is just enough for the distro less for this one.
makes sense. Yeah, thanks.
Great. Good discussions. Yeah.
Great. Yeah, it's much a leaner version of Alpine, I would say, in the Linux family. Yeah. Shall I continue?
Yeah, please, please.
Sure. Thanks, Nibendra, for expanding on build versus runtime image and
My
multi-stage.
pleasure. My pleasure.
Yeah, the multi-stage build is illustrated as just two stage. There could be multiple stage to enable caching also. So one example is the working directory, usage of working directory. Because we have used the working directory, we are able to refer that in our copy stage. Otherwise, this would just go. If we don't store, if we don't have a working directory set, we could not refer that back. That is also one strategy you can use when you are building image. This one is mostly is not used in platform engineering stuff. Cloud native build packs. I don't know, at least not at my orgs. This was used in and Cloud Foundry as per author also. Uh, one use case I can imagine about this thing is okay. First, we'll talk about what it is. So, cloud native build pack is automatically
Anybody
set.
can hear? Okay, sorry. Rajesh, you are not audible for some time.
How is it?
You
Is it
said
okay
that,
now?
yeah, yeah. It's saying that one use case you can imagine, and then you are not audible. Yeah.
Okay. So one use case I imagine is that uh, when we have audience, developer audience from a very wide category, and we can't quality gate them or ask them to learn about something, this would be useful. And that's what Heroku and Cloud Foundry is doing. As you know, Heroku is very general platform. Anyone can go and deploy their app. So what it does is, in cloud native build pack, once you have a code base, it's whether .NET, Java, or whatever, Go, it will automatically sense the source code. When you check in, the build process kicks in, and image building also is done as a part of build process. You no need to bother about building the image on your own. The system would take care of that. That's what the cloud native build packs talks about. So this is a system, it's a concept we are, and it's been introduced here. But I think practically this is not used. Is anyone is using such a thing on your company? Which means when developer just submits their code base, and you go and build the images for them. For example, going back here, this one is a example of an a Go application. So in typical developer environment, the platform engineering will provide infrastructure. A developer would do the Docker file like this, and they will do the pipeline and deployment, all the stuff. uh, which means we know we need them to know about containerization and basics of Kubernetes, all those things. But in this case, a developer no need to do such thing. uh, they need to just write and submit, then it will be built and deployed automatically. So that's what it does.
So I think for Red Hat OpenShift, right, they have a concept of source to image
Hmm.
that I think does something like this.
Okay.
Or people have built some of the PaaS offering on top of Kubernetes that will also use that. So in source to image, what happens is basically you just need to point to the image repository, right? And then the source to build, basically as you can see in the image there, right? They have different ways to check different image types. For example, you can see on that image right on the left hand side top, you have
Yeah.
build packs for Java, Node.js, and so on, right?
Yeah.
So based on your code base, it would look at what build pack I have to use, and then it will do a remaining stuff for the end user. It
Yeah.
most likely is going to be perfect. I mean, it's going to work out, but sometimes we need to tweak it as well. But
Hmm.
this is, I think, at least I know that Red Hat OpenShift would be using it a lot. That's what my guess is. I think there is somebody Red Hat OpenShift user is there. He or she can confirm. Yeah, somebody is here. Yeah, so let me just share one link here. So to S2I, so they call it S2I, and then that basically does this. I think does this in the backend. I'll just put this link here. So this would kind of would be something like that. What is mentioned here. Um, so um, so you basically point to a repo, and then it would take care of the remaining stuff. Anyway, we can go forward to kind of go in that, but you can take a look later.
Yeah, sure, sure. Okay, great. Good one.
Very
Again, go for slide. Yeah, finally we come to image registries. So this is a place, as you know, it's a storage area for the containers we'll build. So all the container bakery stuff that their end system would be the image registry. From this place, any other teams, the developer teams or any other cross-functional teams, um, or another platform team, they can consume the images here. And this one has the longest process. If you have a container bakery of your own, this would have a security scan, also checo scan, CV scan, all those stuff. And finally it would go into a registry. The big cloud provider registries are here. And also you can have your own registry. um, then you can have your vetting process and have it secured with the service accounts. So whenever there is a pipeline which is requiring an image, it needs to supply the credentials before it can fetch. And also we can make sure as a part of building another image on top of the base image from registries, that it has to come from bakery, not from anywhere else. You can't just pull it from the internet. Even it is official image, we can reject it. So that is importance of having image registry. So which is internal assurance for secure access of the image. So once we scan everything, because it's a longest process, we would need to spend some time on scanning and securing an image. Then we would deem that this is a secure image and it can be fetched. That is why we have such a thing on platform engineering. And most of the project have one or other way of having this registries, either through the cloud provider or cell phone. Um, yeah, so this is what I was talking about CVE. There is a Docker command also available, Docker Scout, for scanning these kind of commonly known vulnerabilities. So when you are building the image, this can be scanned against CVEs. So along with the other security practice, you can also have this. This is a one common one, having a CV scans on your image during the pipeline process. So there is a illustration for quarantine also. So when you're sometime you will need to retire the image. Uh, so you need to have a life cycle for how to when the image has to go out of use. For example, if some of your references are all needs to rebuild from the scratch, and what you have currently is no more usable without having a lot of configuration change and other stuff, you can retire it. There is a retirement cycle. This is um, general stuff. I don't think unless your image, the container bakery have a security requirement, this quarantine would not be a concern. But this is an too advanced concepts. If anyone using quarantine on your company, let me know. I think I take it as a no. Okay, fine. Also, yeah, this is what I was talking when before starting the call. Image signing is something again I don't think most of the organization use because of its complexity. So once the image is built, assigning them with a key, maybe it's helpful to harden the integrity of the image, but that's also increases the complexity. So when you are building the image, the typical process is to run with the non-root user, also to fetch the image from the container bakery, and don't allow any other than the allowed service account to build and deploy. These are the stuff is very common, but this is again unless you have a very very strict level of security requirement. Even I work for something, some organization which has a very secure and government one. They are not using it. This kind of stuff.
Or is it that's surprising to hear
Ah,
that even if in government they are not using that? Okay.
yeah, yeah, government. I have worked with government organizations. They are not using this kind of stuff.
Okay.
Instead of that, the alternative. I'm not saying that this is are recommended, but
Mm-hmm.
this is too much of work. That's why the alternative is during your building the containers or
Mm-hmm.
the image container bakery, you'll need to have the practices. There is a separate product we had to secure and scan the images. That
Mm-hmm.
is why all the golden image concepts comes. Either we'll need to get that subscribe the images from best known organization like Amazon,
Mm-hmm.
or we need to have a process of building the golden image ourselves with lots of security scanning tools, both at development, at run, and build time. So development time we can have Checo. Checo is a tool. I think
Mm-hmm.
some of us is already familiar with. And for scanning, there are a lot of stuff. Is there a CVE one, and there could be custom tools. We had used custom tools. I could not reveal more about that. So yeah, these are stuff we can use.
Okay. So have you heard about cosine? Cosine does something similar, right? Cosine and
Yeah,
all these things have come in picture, right?
yeah, and also Google has a binary sign. Uh,
Okay.
yeah, unless it is taken care by cloud provider by themselves,
Uh,
and signing ourselves with the certificates for every stage is really tedious process.
yes.
And signing and reading it, it is going to create an issue definitely, because this is flowing through multiple stage, and sometime you will get a key problem at the receiving end, and you will have to spend some time to fix it. So this is really complex, and I think not worth.
Okay. Good to hear that. Not worth. How?
There are some tools, even book also, it was highlighted. This is really complex. There is a tool if someone wants to experiment. There's a tool from Docker. It's a notary, which actually does the signing process for just for fun. You can experiment this one. Uh, yeah, we are into final section. How much we have? We have 10 minutes. I think we can cover. This is where the interesting stuff comes. If you have not experimented with Argo CD, this is where Argo CD comes. So far, we have spoke about how to build, what is the best practices, how to pack them, all the stuff. Now it comes to delivery part. It has to be delivered through pipeline, but after so typical delivery is when you do apply, it has to go, it has to deliver something, and there will be a Kubernetes deployment, all those things, if it is a Kubernetes. But otherwise, whatever your script says, it will be there. What happens if someone have changed it after that? Someone who has elevated rights, and who can just go and change it in the server after deployment, and that's where the continuous delivery comes in. So the Argo CD, the tool, like, again, talks about another native uh, feature which is called Tecton, which I'm not going to talk, because the similar tool typically used is GitLab. Um, GitLab is dealing with the deployments as well. Um, Tecton, in otherwise, it's a Kubernetes cloud native. What is being argued that this can just deliver as required by Kubernetes and without much configuration, but this is not something widely used, unless someone have a thought. I will skip this part. I'll go to straightly this push-based deployment on the Argo CD, so we can have a conversation. So the push based one is all what I was talking about. So you have an artifact, an image built, and deploying directly would not be scalable stuff. What we can do is, can be, for example, RDS. You built a RDS image, and with the configuration, everything, you have a latest with the latest configuration, which talks about an additional stuff you need to do with RDS. For example, some kind of logging, and you have an image, the latest one, and you have a tag. You can directly deploy it. Also, you can refer that image and keep it for later. That YAML file, or the HashiCorp Terraform based configuration reference, would be helpful at later point. That is where the Argo CD also comes in picture. When you have an image built, and you created a tag, and you keep it in your repo, that is reference, that can be referenced anytime in your pipeline process, and one of your YAML file refers that, that can be further referred by something called these kind of tools, Argo CD, later. But this one is, it talks about general depiction of how the image reference can be further useful for triggering the deployment into it, instead of pushing the image itself. We jump into the GitOps. We'll briefly about these rollout concepts. We have used Canary one. Canary is something that you have some change. For example, your payment module has an upgrade, and you want to test it uh, before, during the production deployment. You want to test it, so you can do that for 1% user. For example, you know that a particular user known about this delivery, and you can just share them the URL and take it forward. Once it is done, you can release to the other set of users, which is who are not even know that this is a new deployment set of small percentage of people for your customer, 10% for example to start with. And when you observe that there is no issue, you can slowly increase amount of people that can use the new version by redirecting to the newest one. That is Canary. Blue green is big bang one. So you have completely new a lot of changes. You are not affording just redirection in service, but redirection in everything. It's a complete infra level change. So then you can consider this blue green, not necessarily infra change. You have major change, also it could be infra change. And so you need a big bang. For some reason you need a big bang. You can't just redirect a small portion of it for a set of time and increase the traffic over the time. You need a big bang and a stretch. Then blue green will be the answer. Blue green something that you have two boxes, and you will check during the development, during the testing. You will do the test. You will do the test, and you will make sure that everything is in place. Then you'll after the go ahead, you just change the system from this blue to green. Yeah, that is what it is. And A/B testing is again, for example, you have an organization, something called, have you heard about Product Hunt? Or you can take Netflix. So Netflix have a different UI, and they want to test for some kind of audience. They can randomly switch people. For example, they will choose India audience. They'll choose some bunch of Asian audience. They will do some test, and another set of users can be from North America. They can do some test. So it can be split traffic between AB. This is mostly marketing level of requirement than infra level or product level. But these are typical stuff that is used in terms of general application development, especially the Canary one.
Yep.
Any thoughts? Yeah, Nipendra.
So there were, I think, some more points mentioned in the chat as well, and then I think we did not discuss much about the image tagging and meta information, right? So that I think we did not cover, but as kind of mentioned in the book there, right? Uh, mm, the way it typically works is I think you are going to come back to that. Not sure what's your plan. If you go back to that figure number 15.04, I think a bit, yeah, this particular figure only, correct?
Hmm.
Um, so what this particular image talks about, right? There's two things to it. One is, of course, um, uh, basically how do you tag the different images, that I think people have been doing in different ways, like giving a version to it. But whomsoever I have worked with, and even for my organization as well, we have been using the git commit id as a image tag, and that is how we have been handling that. And now, what this particular image, what is on the screen, it's saying that, which is image that is coming under the push-based deployment, right? So the way it typically is there is, I think I have used this thing with the help of Jenkins and Argo CD. Um, so the way it works is basically a developer would push the changes to the Git repo. And then once the changes has been gone, then of course you would run the typical pipeline of CI. And then at the part of CI, we kind of build the image and push it to a registry. So think about there are two different image or the Git commit ID you had, right? Um, so of course there are two different versions now of the software. And what we are doing is we are also managing, let's say, think about a very simple, think about another Git repo, for example, and that Git repo or something else which contains your deployment YML, which mentions your image version, what you have to do. So now what I'll be doing is as a part of my CI/CD pipeline, once I basically finish my work of building an image, I would go to other repo and then update that image version there, which my clusters or whatever Jenkins have running, whatever, it would look into that. And because the change was there, it will pick it up and take it from there. I'm not sure if it makes sense or not completely, but the idea is simple that you make a commit, it would build a new image. There's a separate repo that contains only your deployment.yml or think about Helm chart. You update the Helm chart with the new image version and kind of take it forward from there. Um, yeah, so that's what is meant. Tag can be created against the commit ID, and then you can map it, right? Because you, for sure, you know that for this commit ID, this image has been built. That is how it is. And I think if we pick up the Argo as a next book, then I think we'll go in great detail of that. So I think we can, for this particular thing, I think this is sufficient. But if you have other questions, you can please ask them. Go ahead, Rajesh.
Yeah, great. Thank you, Nipendra. Yeah, as Nipendra was saying, you can create a tag for commit ID, or you can refer the commit ID directly. That's your choice. But the best practice is to create a tag for a commit ID in order to make sure that you also mention why this commit ID is being created, what is the purpose, why it can be referenced for the upcoming changes, all those things. So the any developers, engineers who is coming after some time, they will refer to this the tag, and also this will be acting as a history, especially when you are dealing with the base images. This is best practices to create a tags against the commit IDs for every changes you do. Finally, I'll touch. If we spare another 5 minutes, we'll cover this.
Yeah, please let's finish this here.
Yeah. So GitOps. This is where we slightly touched upon last time. So once you deploy, and if anything happens afterwards, we don't have any control. That is where the GitOps flow comes in. So it assures you that the source code can be a single source of truth. So when you have something committed in your Git repo, then the Argo CD takes care of syncing the states based on the code base you have. That is a guarantee it provides. So this picture talks about you are pushing a code and some build triggered, then the image written into YAML file. The image version pushed into registry, and then parallelly there is a image version written to YAML. So you see parallelly happening, the image pushed into image registry. Also the equivalent YAML is going to be in the repo. So this will be acting as your uh, future reference. So this is where the Argo CD comes in. So this will be watched by GitOps controller, in this case Argo CD. Then it will sync based on the repo state. I have a quick example for that. Um, Argo CD. So as you see, um, Argo CD app create gust book.
It's
Uh,
not visible. Can you increase the font, please?
yeah, just a minute. Is it visible?
Yeah, decent. Yeah. Sure.
So this is a way you will create a Argo CD app in this way. Argo CD app create gustbook, some random gustbook, and repo. In this case, this one, I'll go there. So this one have multiple repo. What we are interested in Gus book. Remember this Gus book. Just a moment. And how the Argo CD configuration works is we have pointed a repo. We'll have to point a path. Path is here Gus book. So we are going inside the Gus book. So inside you see inside whatever the YAML file, manifest file that Ergo CD sees, it will try to replicate that into the deployment. That's how the Argo CD works. You can have it in multiple folders. It doesn't matter. It will just see .yaml file, and as far as it is a manifest, to look for the kind, it will just replicate that in a cluster. That is the guarantee it provides. If you delete something accidentally, it will just recreate it. Yeah, that's what I want to share, and I will ping this for further reference and playing around. I think, yeah, with that brief, I think it's done. Until further questions, we can wrap it. If we have questions, we can discuss.
Okay, thank you, Rajesh, for the session. And this would bring us, I think you really did a kind of commendable job for kind of doing two sessions back to back. The previous
Right.
and this one, thank you again for taking that um, a step and then help us as a have at that in that community there. So now the same question as I always ask, right? Is the last chapter what we have, and if anybody want to volunteer, you can just ping me or just reach me in any way, LinkedIn, Twitter, whichever you would wish. The last chapter is there, and of course after that we are going to go for the next book, which we have to pick it up. So let me just kind of bring it the session or what we call say the list of the three books which we thought of doing. So for people who are, if you are there in the channel, Slack channel, all of them were mentioned. So one of the book which is on Argo CD, I'll put the link here quickly and then kind of close for today. But I'll just give the link and we decide later time. But I just want to leave the link here that you can kind of go back and take a look, and then we can finalize on the next time. And then because post that we have to kind of um, go for the next book, right? So I just mentioned two books, two links. Let me look at the third link as well. Yeah, we have three books we thought of, but of course we are open for other suggestion as well. But one thing we thought of is because as you know this book has taken around I don't know 7 months I think almost to finish the book, which is production Kubernetes, kind of mostly theoretical, not much of a hands-on, though we did some demos in between. But the next book we want to pick it up is the something which is more hands-on. So one, this practical book which we are thinking of, which is of Argo CD, and that is the book which is one of the thing which is there. But again, we are open for suggestions. If you have suggestions, please bring in. Okay, third link is duplicate. Okay, let me put up that. So channel name is Kubernetes Book Club under CNCF. So you kind of go to this particular CNCF Slack channel and get the thing. But let me give the book here. The third book is this one, observability engineering book. But this would be again, I think, mostly there, theoretical right now. But okay, anyway, I don't know much about. I have read this book a long time back, but I don't know whether it's a lot of hands-on is there or not. So the only thing we are thinking for the next time, we'll do more hands-on stuff so that we can do more demos and make it more interesting. That's the idea, but we can take it something else as well. Yeah. So please put your suggestions on the Slack channel. We'll pick it from there, and the next session we definitely decide what the next book will take. Yeah. So see you guys in the next week. I hope to see you all. And if you want to really take the next chapter, please ping me by tomorrow. Otherwise, I'll take it by default. So that's how it is at this point of time. So yeah, thank you guys for joining in, and see you soon. Yeah. Bye bye.
Thank you.
Thanks for hosting. Great session. Thank you.
Thank you. Bye bye.